Hello everyone. Today let's solve the problem number 102, binary tree level order traversal. So what the question states here, we are given the root of the binary tree. So see here, we are given the root of the binary tree and we have to return the level order traversal of its node values. So in level order traversal, we visit all the nodes level by level from left to right. From left to right, see here 3, 9, 20, then 15, 7. Right? So that's what they have given in the question here. So just give me a second. 3, this is level, this is one level, this is level, right? So here in the level order traversal, we visit all the nodes level by level from left to right. So we need to return a list of lists where each inner list contains the node values of one level, right? So they have clearly mentioned here we need to return the list of lists where each inner list consists of the node values of one level, right? So here first we need to return 3 within one array, then we have to return 9 comma 20 because this is one level, this is the second level, right? So the third level here consists of the 15 comma 7, 15 comma 7. We need to return this one in another array. This is complete array, right? So that's what they have given. We have to return a list of lists where each inner list contains the node values of one level. So if the tree is empty, then we have to return empty list. So if the tree is empty, suppose input consisting of this one empty. If the tree is empty, then we have to return the empty list, right? So I hope this part is completely clear, man. Just give me a second here. 1 second. Yeah, this is fine. So let's come to the first example. We have already discussed the same thing, right? So here in this case, we have 3, 9, 20 and 15, 7. So the output that we need to get here is 3, 9, 20, 3 within one thing because this is the first level, this is the second level, and this is the third level. 3, 9, 20 and 15, 7. This is fine. So the next part here is just 1 second, one. The next part here is second one, root one we have only one element we have, so we have to return that one within the array, right? So that itself only one level we have, right? So here in the question they have strictly mentioned that if the tree is empty then we have to return the empty list. So here we have to return empty list. This is it, right? So let me remove this one entirely, man. Let me remove this one entirely. Yeah, now I hope the question is completely clear along with the examples. Now as we are done with the question part, let's quickly discuss the approach part as well. Let's quickly discuss the approach part, right? So then followed by the complexities and then let's write the code. First thing here is we will be starting with the root node. We will be starting with the root node. Just give me a second here. 1 second. Yeah, let me keep it like this. Yeah, we will start with the root node, this one 3, and we will add it this one to the queue. So we'll be making use of the queue for this particular problem. We'll be going with the queue. So we will start with the root node, basically BFS. We'll be going with the BFS, breadth first search, as we have to display this one level by level within the output. So we'll be going with the breadth first search. First thing we will start with the root node and then we will add that one to the queue. Means this is level 0, this is considered as level 0, this is considered as level 1, this is considered as level 2. So what we'll do, we'll start with the root node 3 and we'll add that one to the queue, nothing but level 0, right? So this one will be 3 now. This consists of 3. Level 0 consists of 3, right? So this is fine. The next step is next level is we will pop 3. We will pop 3 and add its children 9 and 20 to the queue. So we will pop 3. We will pop 3 and then we will add the children of 3, that is nothing but 9 and 20 to the queue, right? So now L1 consists of this one, level 1 consists of what it consists of 9 and 20, nothing but the children of 3, right? So now L1 consists of 9 comma 20, right? So next level is we will pop 9. We will pop 9, this one we will pop 9, only 9, right? So we pop 3, we had only one element, so we popped 3 here. So now we will pop 9 and 20. So first we will pop 9 and second we'll pop 20, right? So we will pop 9 and 20 here and add their children. Means here 9 doesn't have any child node, and for the 20 we have two children right here, 15 and 7. So we will be adding the children 15 and 7, right? So now the queue consists of means level 2 basically. Queue or the this one L2 consists of level 2 consists of here this one 15 and 7. 15 and 7, right? So 15 and 7 basically. So here no more nodes are left. We are done with the nodes, right? We are done with the nodes. No more nodes are left. So here the final output is 3, 9, 20, 15 and 7. So this one we can write it in this way. 3, this is nothing but 9 comma 20, and the final one is nothing but 15 comma 7. 15 comma 7. So this is fine. So this is the output that we got, which is equivalent to the output that they have shown for the example one within the question. So our approach works absolutely correct in this case. Our approach works absolutely correct in this case. Now let's quickly discuss the complexities. So the time complexity would be big of n here. So the time complexity would be big of n. So why the time complexity is big of n? So every node is being visited once exactly during the BFS traversal accordingly with the approach that we discussed. So quite obviously the time complexity would be big of n, and the space complexity would be big of n as well. Why it is big of n? The space complexity would be big of n because Q stores up to n nodes. Q stores up to n nodes in the first case, right? So the overall space complexity would be big of n as well. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n, right? I hope the complexities part is completely clear, man, right? So now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So here the first part would be this one. We have to store the final level order traversal within the result, right? So I'll just go with list. So this one would be list. So this will be integer. So this has to be capital I, not the small. This is fine. Integer. We are we are making use of the array list here, right? So this is fine. Syntax. The next part is let's go with the edge case. Nothing but for the empty tree. If the tree is empty, then we have to just return the empty array in that case, right? So we have to articulate same thing in the form of code here. So this one will be root equals null. Then we have to return result. Then we have to return result. So this is fine. The third step is we have to queue to process the nodes level by level. We have to queue to process nodes level by level. So this one is queue tree node. So this is fine. This one is queue new. This is linked list, new linked list. So this is fine. New linked list. After making use of the queue to process the nodes level by level, we have to start with the root node every time. Not every time, but yeah, for every time. So we have to start with the root. So I'll just go with the queue dot add of root. We can articulate in the form of code in this way, right? So we are done with this part. Let's go with the pure queue here. So while queue is not empty, I'll just make use of is empty here. So within this, we have to go with the number of nodes in the current level first. So let me make use of the variable name size and let me assign this one to q dot size. So this is fine. So we are going with the number of nodes in the current level. Next step is we have to go, or we will be going with the list to store the current level values. Means I'll just go with list here. This will be integer. So this one will be level new array list. So new array list. So this is fine. So the next step is let's go with the for loop. This one will be int I equals 0, I less than size. Then let's increment the I here. So within the for loop, what we'll be doing, we have to get the front node. So I'll just go with tree node, variable node. Let me assign this one to the, to get the front node, let me make use of the poll operation here. This is fine. We are just getting the front node. After getting the front node, we have to add its value to the current level list as well. So I'll just go with the level dot add of node dot val. So this is fine. So I hope this part is completely clear, man. Final two steps is we have to add the left child if it exists. Also, we have to add the right child if it exists. So let me write in this way: node dot left. If it is not equal to null, then let me go with q dot add of node dot left here. Let me copy the same thing for the right node as well. Means if we have to add the right child if it exists basically. So let me make the necessary changes here. Just go with the right here. Just go with the right here as well. So this is fine, man. Uh, mm, just give me a second here. Yeah, here what shall we do? We have to add the current level to the result. Means I'll just go with the result dot add of this one will be level. This one will be level. This is fine. The final step would be we have to return the final result. Means I'll just go with the return uh, result. So this is fine. We have to go with the return result. So let me format the code once and let me hit the submit button. So I should have hit the run button. That's fine. So we have the compile error here. What error we have? List. Mm, Let me hit the run button, man. Line number 3. So what error we have? Not a statement. Line number 3. So what I am doing here? List. Within the list again. So this is fine. This is also fine. We are going with the type integer. Type integer. This is fine. Oh, I have not given the variable name at all here. So that is the reason it is saying not a statement. So I'll just give here result. We are storing this one in the result, right? I have made use of the result here. So yeah, let me hit the run button again. Yeah, now the sample test cases are getting passed. So let me hit the submit button quickly. I hope all the test cases get passed. Yeah, see here, you can clearly see here all the test cases are getting passed. Means the code works absolutely correct on this case. I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.